Hello, this is Santosh Thapa. I'm a distance learning student of this semester for Big Data, and this is the project proposal phase. And my topic is data analytics on airlines traffic. So the the flights. I mean, the flights area is like a very soaring industry. Uh, we can look at the flightradar.com and see that in a minute there are almost 75,000 air flights taking place in a minute. So such huge data, we can use those data by using data analytics, and we can predict the on time airline performance. So this is the main uh, objective of this project. The dataset is of 3 consecutive years: 2013, 2014, and 2015. These are the individual data of flights taken place in USA, which was extracted from Bureau of Transportation Statistics. Data analytic technologies which will be used for this project are MapReduce, Spark, and Hive. The mainly the output of this project will simply summarize the available data by time periods, airport, and carrier. Carrier meaning the airlines. And similarly, there will be the temporal effects, spatial effects, and carrier effects output. Temporal effects such as time periods more prone to delays than others will be determined, uh, meaning that the which of the time period is more prone to delays. Is it in the morning, or is it in the evening, or is it in the afternoon time? Similarly, special effects like airports, which are more prone to delays, and finally the carrier effects, like if some airlines such as Virgin Atlantic airline is more prone to delays, or others. So the main problem statement of this of the airline industry is there are a lot of uncertain flight delays which are unexpected, and which have been delayed or either cancelled, which is very troublesome to the passengers. So depending upon the time period of the day, month, or certain season, maybe winter, fall, or spring, the on-time performance of the flights becomes unattainable. So the and also the fly the this makes the flights get delayed and cancelled in some cases. So the objective of this project will be to find out the best time of the day or week or year with medium delays, so that the passenger can just take find out the best time, or which day is more prominent to medium delays, like is it a Sunday that will be less delays, or Monday, similar like that. And to find out the flight departures having delays more than 15 minutes. Similarly, to check out if the older planes are more prone to delays, and then to know if the weather has any effect on the flight delays. Similarly, to detect the relational failure delays with respect to one airport, such as if a flight is uh, coming from JFK airport to the Texas airport, does the delays caused in the JFK airport has effect on the other planes, other flights in the Texas airport? So this will be also determined in this project. And the data set, as I said, there are three main data sets. The yearly database 2013, 14, and 15, with additional supplementary datasets, carriers, plane data, and airports. The dataset mainly includes domestic flights from year 2013 to 2015. The main attributes are year, month, day of month, departure time, and unique carrier tail number, flight num. Similarly, arrival delay, departure delay, origin destination, IAT, airport code, cancellation code. Reason for cancellation will be depicted in the cancellation code, which is either A, B, C, or D. Similarly, if it's diverted, it will be 1, and if it's not, then 0. and carrier delay with a delay, as delay, and so on. So the supplementary datasets are, as I said, a carrier three supplementary dataset. Carriers, plain data, airports. Carrier has two attributes: unique carrier description. Similarly, plain data has nine attributes, and airport has seven attributes. The unique carrier, tail num, and origin destination are the foreign key for datasets. Um, Carrier, plain data, and airports in the main the yearly database. So the main and data analytic techniques which will be used are MapReduce, Spark, and Hive. There are basically five findings which will be made on this project. One will be done via MapReduce method, another one by Spark, and the others three remaining will be done by a Hive. The MapReduce is simply the framework developed by Apache Hadoop project, which breaks the big data into manageable chunks. It has basically two phases, map and reduce, and in between the shuffle and sort phase is also done to get more defined output. So in here I'm using the map reduce to get the flights departures which were delayed by greater than 15 minutes considering the days, months, and seasons, that is summer, winter, fall, or spring. So in the mapper function, it the mapper function, the the flights unique carrier will be taken as a key and departure delay as a value, and uh, the actual delay, what is the actual delay, which is just simply the difference between the actual departure time and scheduled departure time. And if this time is greater than 15, the delayed variable will be set to 1, and the output will be just simply the variable text and new in writable anti-writable form, and which will be sent to reducer, and on the reducer uh, it will add the set um, the the sum of the flights which were thrown from the mapper. So this is just the pseudo code for the map reducer. Similarly, in the Sparks, I'm using the Spark Scala. I'll be using the Spark Scala with the Hadoop Yarn system, and which will be mainly used to find out the base time of the day or day of the week or time of year with minimum delays. I'll be using the Pythons, and this is Python pseudocode. And so in here, I'll be creating a data frame based on a table named flights, which is the main database, which will be the main mega database formed by the three yearly database, and the flights database will be stored in MySQL database, and this the URL is just a MySQL server with username and password, and similarly the parameter df is used to determine the data SQL server, and then the schema of this data frame is created, which calculates the normal delay, which will then finally be used to determine the minimum delays with respect to the day, time, and corresponding period. So finally, the Hive is a declarative SQL-like language. It minimizes the code length to 4 to 5 lines, getting the same output. So these are there are three findings which will be done on Hive using Hive to check out if the older planes are more prone of delays, which will be just selecting the main attributes here, flight num, variable delay, tail num, and tail num with the year, and from flights with a left outer join of plain data, as tail num is the foreign key on the flights main database, which will be grouped by arrival delay. And similarly, to know if the weather has any effect on the flight's delay or cancellation, we will just select the main attributes which will be needed to find out the flight delays with respect to the weather. And finally, to detect the relational failures like failure delays, so that one delay airport creating delay on another. So it will also select the main attributes which will be used to detect the pattern, and those are the year, flight number, origin and destination, project proposal phase, code, arrival time, for your time, arrival delay, departure delay, and distance from flights.